Hi guys, njani? Ngifuna sifundzeni forces, the grade 11 stuff. Mechanics, they are being assessed in question 2 of your physical science, paper 1. So, ngifuna sicale ngema-Newtons laws. In your exam room, when you enter the exam room, you have to know all the 3 Newton's laws. That is the first law of motion, the second law of motion, and the third law of motion. So you have to know these laws by head or heart. Then you have to know what? You have to know the law of gravitational, Newton's law of gravitational energy. You have to know it by head or heart. So today ngifuna sikhulume ngalama forces. Sathi i-force yini? What is the force? Because you have to know what a force is. It's junior stuff. A force is defined as kind of push or pull of an object, at most in an attempt to change its state of rest or motion. That is a force. One may say is pushing, twisting, or pulling of an object. That is a force. Alright. So I don't think they will ask you that. Is pushing, pulling, or twisting of an object. That is a force. Is measured in Newton. Its symbol yayo is denoted with capital letter F as a symbol. It measured in Newtons as the SI units. And it is a vector quantity. It is a vector. When I say it is a vector, which means we'll consider the magnitude and direction. No, this is and. It's not a dollar sign. And direction. When you consider the force. So there are kinds of forces like contact force and non-contact forces. You have to know them. Most of them are contact force, which we are going to talk about, because we'll be exerting a force to an object, and they are contact force like normal force, force applied, force of friction. They are in contact with an object. So you have to know them. Then let's talk about these forces. Let's start with Kulmao. We'll talk about what? The force applied. The force applied is the force that is being applied to an object, like pushing, pulling on an engine force. Is a force that is being applied in an object. Force applied or an applied force. Is denoted as FA, force applied. So is the one that is being applied. It is externally at most. So this is an external force. Applied to an object. because we are talking about an object here. Then we'll talk about a normal force. The most crucial force is the normal force. This is denoted with capital letter N, or force normal. Alright, it's either you write it like this or that. What is a normal force? Let's consider I am having what? I am having an object on top of my table. This is my book. There's a force that is preventing this book from falling, which means it is applied by what? By the surface of the table on the book. That is the normal force. So it's a force in which is exerted by the surface, and it is perpendicular to the surface. So you consider those two important notes. Maybe you might be asked to define the term normal force. Number one, the force is exerted on an object by the surface, and it is perpendicular to the far surface. So let's define it. We will say normal force. What is normal force? It's a force in which a surface exerts on an object. A force in which a surface exerts on an object which maybe in which it in contact with, which is in contact with, which is perpendicular to the surface. That is a normal force. You have included what? You have included that is a contact force. You have included that it's exerted by the surface. You have included that it is perpendicular to the surface. All right. Kwahamba. Anyway, asiqhubeke siye ku frictional force. Let's talk about frictional force. Frictional force. What is a frictional force? All right. Let's consider a rough surface. Frictional force. Number one, you have to know what it is caused by the surface. It's caused by a surface to which the object more is in contact with. It caused by the surface. All right. Number two, you have to know that friction force resists the movement of an object, which means it prevents it from moving, or it makes it to move more slowly. So it resists the movement of an object. All right. And number three, you have to know that it is parallel to the surface. but it opposes the direction. Is parallel to the surface. It opposes what? Oppose the direction of motion. Okay, so let's consider like I'm having this plane here and I'm having this surface here. If this plane is moving, let's say the surface is rough and the plane is in contact with the surface. So if friction is parallel to the surface, is a force between the surface and an object. It opposes what? The motion. So if here plane friction toyale, if single mixale friction toyale. Alright. It is denoted with small letter f, or you can say force of friction. It's denoted with small letter f, or you can say force of friction. So if you put a small letter, you put a so if you put capital letter, you put a small letter. Alright. So a proper definition here, you will include all these. Will define friction force as what? Will define friction force as a contact force that opposes the motion of an object and which acts parallel to the surface. So you will define frictional force. Frictional force is a contact force that opposes the motion of an object and which acts parallel to the surface. That is a proper definition of a frictional force. You have included that it parallel, you have included that it opposes the motion, you have included that it is in contact force is caused by the surface. So as it's manje ke on an object, this is an object, or apply force la, I humble object, but to apply force I humble object. Uze kudzinga ku-apply force leningi ukukhanze hamba bese libanjwe yini the object ukuthi ngahambi. Alright, ngifuna sikhulume with that, and we call that the static frictional force. So I want us to talk about static frictional force. Is denoted F as lomncane. An object that is not being set in motion by any forces on it by pushing or pulling, it experiences the static frictional force, which means if the object is in stationary, aliko in motion, like box lambe lapha. So if the object is not being set in motion by any other force, it's experiencing a static frictional force. Alright, you can write that down. An object that is not being set on or in motion by any forces acting on it. It's either by pushing or pulling, experiences a static frictional. It experiences a static frictional force. So the static frictional force is equal to the magnitude of the force applied. That's why the object is not moving. F net is 0, which means if I am pushing this object and the object is not moving, it means that the static frictional force is equal to the force applied. So ngicela ukubhale lokho. The static frictional force is equal in magnitude to the applied force. That law of motion. Alright, which we're gonna talk about, which means Fs is equals to Fa if the object is not yet moving. Is not yet moving. Ize ngahamba. Bese ayifusha nje le moto imile. Kusho ukuthi manje ke the force we apply kwilingana nale static frictional force. So you may be asked to investigate the static frictional force. Maybe let us investigate it. Let's say you are having this block here. This question was asked on November 2024 Physical Science Paper 1 final exam, the static frictional force. If the object is on rest and no applied force acting it experiences no static frictional force, right? If an object is on rest and no Fa, it experiences 0 static frictional force. For a frictional force to happen, we said a frictional force opposes what? The motion of an object. So for a frictional force to happen, there must be a force applied, which means if there is no force applied, then object is just there, it's at rest. So if the object is at rest and no one ingaba at rest, ngisho uyifusha, I can push the object and still remains at rest. According to first law, I need a net force to make that object move. If that object is not moving, yet I am pushing it, it means that the static frictional force is equal to the force applied. So no F net. That's why the object is not moving. because we know that according to first law of motion, an object will remain at its state of nature. It will continue to move with a constant velocity, or it will remain at rest unless a net force acts on it. So if there is no net force that is acting on it, it will remain at rest. Even if I do apply the force here, it can remain at rest. Why it remaining at rest while I am applying force is because the force that I am applying is equals to the static frictional force. All right. So we can investigate it by doing that. Go to your physical science NSC final exam 2024 paper 1 question 2. You will find the investigation of this, so you will answer those questions. Then thina nawe ngifuna nyalo sikhulume ngani nge-proper definition that we are going to give this static frictional force. So we will say, let's say I am applying 20 Newton here, and yet this block is not moving, which means my F applied is 20 Newton. Then my F net will be F applied plus the static frictional force, which means since it is not moving, the F net is 0. Then my F applied plus this will be 0, which means my F applied is 20, right? Which means I will have 20. Then I will transport it, so it's negative 20 Newton is equals to static frictional force. If I am increasing this force, I will have what? I will reach the maximum. There's a point where this block would start to move. Just before it starts to move, I think this block will start to move at 50 Newton. When I'm applying 50 Newton, seyaqala move le box lam to the right, which means ku 49.999 the block was not moving. Iqale ukumuva nje exact at 50 Newton. So lapho ngidafuna the maximum. We will call it Fs max, which means the maximum static kinetic lebesinaso del box is lo 50 Newton. So it's the maximum. Ndayiqale khona kumuva. All right. But logically is 49.999 because 50 bese kune F kinetic because bese move now. So but because it's the closest value, we will say is 50 the maximum. All right. Angathi noma uyayithola kusiyini this maximum static frictional force. Is the static frictional. La isukilingana. Mangethe isukilingana. Ilinganiswa yini third law of emotion. Because when I'm applying a force, will apply the same force to opposite direction. Unless ke seyiqala it's rumble. Seyaqala iya move, then you will say ayiqale khona the closest value to the maximum kinetic. Like qale khamba khona. All right. I hope we are ibamba kusiyini static frictional force. Let's give it a proper definition. So if a question may come, define the term static frictional force. You can say static frictional force is the force that opposes the tendency of motion of a stationary object. Relative to the surface. This is a proper definition of the static frictional force. Kumele ungene ku-exam room sila nhlo basibuda nje 2024 November. So let us calculate it using the formula. How to calculate the static frictional force? Let us calculate the static frictional force. So the maximum static frictional force depends on two things, mfana. What you have to know. It depends to the normal force. It depends on two things. So the Fs max depends on two things. Number one is the normal force. We say it's denoted with capital letter N. So if the plane exact on is the normal force that the plane exerts on an object. The greater the weight of an object, the greater the normal force, right? Which means the harder the surface press against each other. If I am having a plane here, I am having these big building block, steel. So if ungeta lesinye steel ngetulo, usho kutsini lokho? That means there will be greater contact between the surface and an object. Therefore, it will be harder. The surface and the object will press the surface more harder. If the object presses the surface more hard, I will need more force to move this object. Which means if there is a higher weight of an object, the Fs max is also high. It's directly proportional, the maximum, to the weight of an object. Why so? Because the greater weight of an object make it harder. The surface, it makes the surface and an object to press each other against each other very hard. So a greater upright force will be required to move an object. That's why it depends what? It depends to the normal force. Alright. Another thing, the static frictional force depends on the material of the surface. So it depends on the material of the surface. What do I mean when I say it depends on the material of the surface? If this block here is on a very rough surface, it will be very hard for me to move this block. If it is smooth, ingaba nenang lenkulu, but uthole ukuthi incane le static frictional. So that is how it depends to the material of the surface. One may say, and the decomposition of the material. What do I mean when I say the decomposition of the material? How easily the material is being eroded by me moving this block. Let's assume that this block is on a plank and another block is on a just ground, a rocky ground. You see that the one on a plank, due to the smoothness, and the plank will be eroded. And if there went a crunching experience between the surface and the block, so it will be easily for the surface to decompose on the path that will be taken will be easy to be decomposed. And if a rough surface maybe is on a rocky surface, it will be hard for the rock to be decomposed. So which means the roughness, the roughness of the material contribute to the static frictional force, roughness and decomposition of the material. All right. Then the formula of calculating the maximum static kinetic force will be given as mu s times normal. And I have introduced something that is mu. What is this thing? This thing is a proportional constant. It's just the ratio of the F max and normal. It doesn't have unit and is always less than 1. It's just a unique value. It combines the two surfaces experiencing friction. In the combination of frictionless, then it is 0. For a rough or sticky surface combination, it becomes closer to 1. It does not have units. All right. Then let's talk about the kinetic FK manje, which is the kinetic frictional force. Then after kinetic frictional force, we'll talk about non-contact forces. All right. Let's talk about kinetic frictional force. Is denoted as Fk. All right. we said as soon as this object starts to move or it being set in motion, it no longer experiences a static frictional force, but rather the kinetic frictional force is counteracting its motion. So you can write it down if you think you cannot grab it. As soon as an object is set on motion, it experiences state kinetic frictional force, which means so ngame konke lokho ma forces back now yaqala. That is the reason iba incane the kinetic frictional force than the static maximum frictional force. Alright, a smaller applied force is required to keep the object to move contact. That's why kudzingeka amandla lakucaleni kakhulu, waze yaqala kuhamba le object, I won't need much force. I'll just need a smaller force to keep this object on moving. Alright, so as soon as the object starts so the Fk is smaller than Fs max. Alright, the kinetic frictional force depends on two things now. Number one, the normal force of the plane. Number two, the coefficient of kinetic force. So Fk also depends to F. And do you see now I'm having mu n, not mu s. This is the coefficient of kinetic frictional force. That one was the coefficient of static friction. This is a coefficient of kinetic, does not have units, frictional force is known as mu k. So usebenzisa le if you calculate a frictional force of a moving object. Alright, and it also depends on what? So it depends on this value and also depends on normal, and it's directly proportional to normal, which means if a normal force decreases, it decreases in a frictional force. If normal force increases, it increases in a frictional force. It's directly proportional. Alright, then what is the definition, the proper one, of a kinetic frictional force? Because we have said a proper definition of a static frictional force is the force that opposes the tendency of motion of a stationary object relative to the surface. Here is the force that, and then a kinetic frictional force is the force that opposes the motion of an object relative to the surface in which is in contact. Alright, so kinetic frictional force is the force that opposes the motion of a moving object manje, moving object relative to a surface with which is in contact. That is 2 marks for free if bakubuzile. All right, then is 40 minutes. I will talk about non-contact forces. Then after talking about non-contact forces, we'll draw free body diagrams. All right. All right.